This is chapter 5, and let's go along. So let's look at the objectives. Define and use properly in context all new terminology to include scatter plot. So a scatter plot is a plot on which the horizontal axis has the explanatory variable and the vertical axis has the response variable, and each dot represents the relationship for a specific case or observational unit between these two variables. What is a dot plot? A dot plot is something like this. It is basically a one-dimensional graph in which the observation or case for a single variable is plotted within the range of that variable. So this would be the range for this particular variable. Now, what is the mean? The mean is the center of the distribution of data and is commonly referred to as the average as well. And it is calculated as the sum of the observations divided by the total number of observations. Now, let's talk about distribution. Now, distribution can be referring to how the data is appears in specific graphs. So like, for example, in dot plots or in histograms, for example. Point estimate. What is a point estimate? A point estimate, let's read the book for this one. So we do talk about numerical data here. And then this is an example of a scatter plot. And so right here, a scatter plot provides a case-by-case view of data for two numerical variables, as we were saying. Now let's look down. What do scatter plots reveal about data that might be useful? I'd say they reveal whether there's an associations. For strictly spotting association between variables, whether those associations represent simple or more complex relationships like this one right here. Now, dot plot, here's an example of a dot plot, is a one variable scatter plot right here. And the mean is a common way to measure the center of a distribution. The distribution of a variable is essentially the collection of all variables, and that's the one I didn't have a definition of, is the collection of all variables in the data set. It tells us what values the variable takes on and how often. So this is an important definition, my bad. It's an important definition. The distribution of a variable is essentially the collection of all values of the variable in the data set. Collection of all values of the variable in the data set. Let's not forget that. All right, let's go back and see what other things we have. We talked about the distribution. What is a distribution? You repeat, and then I repeat it. All right, my turn. It is the collection of all the values of the variable within the data set. Point estimate. Let's look at the point estimate definition. So the sample mean may provide an estimate, and while this number will not be perfect, it provides a point estimate, a single plausible value of the population mean. So a point estimate essentially is a single number that summarizes some sort of quality of the set. Now, let's talk about weighted mean. A weighted mean is a particular type of mean in which we consider some variable to have a greater effect and other variables to have a smaller effect on the overall result of that point estimate, which is the average. Is an average in which some observation contribute more weight than others. Okay? Some observation contribute more weight than others. That's also a good definition. Right. So now let's talk about a histogram. So a histogram is something that looks like this. And it is good to tell us a lot of things. For example, a histogram can tell us roughly in the bin the mode, which is the value that is observed more often, but more loosely speaking, because in general we don't necessarily have the same value repeated twice in a data set, it has a little bit of a more specific definition. And what is the definition? Let me just go over here. And is represented by a prominent peak in the distribution. So the value with most occurrences. It is common to have no observation with the same data set, which makes the other definition useless for many real data sets. So we need to use a prominent peak in the distribution. Now let's go back and let's look at the definition of a histogram. The definition of a histogram is right here. It displays the distribution of a quantitative variable, and it shows bin counts, the number of observations in a bin or range of values. Now, these plots, these histograms can be right skewed if the tail is skewed to the right. So if they have small observation to the right, don't get that wrong, or left skewed or symmetrical, so it gives us a sense of the distribution of the data. This is the command used, gf histogram. Now remember to include we're only going to have tilde and an independent variable, and then you have some options like fill if you want it proportional and things like that you have to explore. And then they're good at telling us the mode, which is a prominent peak in the data. Here, there's a single prominent peak in the data, so that would be unimodal, and I would also say that this is symmetrical. This is bimodal because there's two prominent peaks in the data, and this is multimodal because you see there's more than one or more than two prominent peaks in the data. Then we have some other definitions here for variance and standard deviation. So let's look at variance and standard deviation. But we first define standard deviation because we first define variance, I would think, is the average squared distance from the mean. And it is a way to measure the spread of the data. And again, it is different than the histogram, right? It is a numerical value. And why is the distance squared? Because it takes care of the fact that some distances are positive, some distances are negative, and if you were to add them up together, you would have certain terms cancel each other out, and you don't want that because overall they're all away from the mean, right? So it's the average squared distance from the mean. So you first calculate the mean, and then you calculate the average square distance after taking each term, finding the distance from the mean, squaring it, adding it up all together, and then dividing by the number of observations, or the number of observations minus 1. That's what you do in the sample, while what you do in the population is you actually divide by the number of observations. And then before you take the square root, that would be variance. And then standard deviation is the square root of variance, and it describes how close the data is to the mean. Then we have other stuff, which is pretty important, which is box plots. So let's go back up, and we're almost done. We're right here. What is a box plot? It is a particular type of plot that displays the median, which is the middle value of the data, but not in the same way as the mean is. It is the middle value of the data for distributed quantitative data and for ordered quantitative data. So, for example, you have 6 observations, and so the fourth one, the third and the fourth, you take the average of those two, so you add the third observation, the fourth observation, divided by 2, and that would be your median. If you had an odd number of observations, like 7, then the fourth observation in order would be your median. The interquartile range is the middle 50% of the data, and it is displayed in a box plot. Then we have the first quartile, so right here. The first quartile would be this one right here, Q sub 1. Second quartile would be this right here. This is the median. Third quartile, and then this would be the fourth quartile. Now you can have outliers, which are, for the purposes of this graph, are observations that are not within 1.5 the interquartile range, which is the middle 50% of the data. And those are outliers. And then what other definitions do we have? We have a robust estimate and then transformation. Now, robust estimate is a type of estimate or robust statistic that is not influenced by the presence of outliers. So say the median is not influenced because even say you have 7 data points, your median is the 4th data point with the data points ordered. Say you take the 7th observation, you throw it away and you put an observation that's higher, that's going to change the mean, but not the median, because the median will still be in the middle. And so that's an example of a robust statistics. Okay. Finally, we have transformation here, which is this one right here. When data is strongly skewed, we sometimes transform them so that they are easier to model. So say, for example, this histogram of Major League basketball players, which is shown in this figure. There are some standard transformations that are often applied when much of the data cluster near 0. So like a rescaling of the data using a function. For instance, the plot of the natural logarithm of player salaries results in a new histogram. Sometimes we apply this transformation to see the data better. Well, I think this was a pretty challenging chapter in terms of all these definitions, but I hope that these weren't too obscure after the explanation. And I'll see you on chapter 6.